This is the last, this is like a draft.
Okay, so we all should have our new packets here. We're going to go get started with this next chapter, which, like I said, is going to be all about matrices. Now, last year in Algebra 2, you maybe talked a little bit about matrices. I know we kept it pretty simple last year as far as like operations with matrices, like being able to add, subtract, and multiply the elements inside of a matrix. And we also talked about how to use a matrix to help us solve a system of equations. And that's something that we're going to still do in this unit. Like our last chapter was all about systems of equations in 2 variables, 3 variables, and all of that stuff. So we're still going to use some of that, but now we're going to switch it a little bit into how do we use a matrix to help us solve a system of equations instead of having to use graphing or substitution or elimination. How can a matrix help us do that same thing and still get answers for our system of equations? So we're today going to kind of keep it simple as far as like talk about the dimensions of a matrix, how you read a matrix, and then how we do some like basic matrix operation, like if we want to change elements to make it work better for us, so that you can start to see towards the middle and end of this section how it's going to lead into solving those systems of equations. All right, so a matrix is just a rectangular array of real numbers. And so I kind of gave that example on the bell ringer where you'll have like those matrix brackets and they'll have terms on the inside, okay? A number inside of the matrix is just called an entry. And the rows would be your horizontal lines in your matrix and your columns would be your vertical lines. When you're trying to talk about the dimensions of a matrix, it's always rows by columns. Okay, so when they write something like this here where it says C, C is like a capital letter that they're using to just talk about the matrix in general. And when they say 3 by 4, they're talking about number of rows by number of columns. So the matrix would be called C. The size is 3 by 4 because there's 3 rows and there's 4 columns. You can really have any size matrix you want. So they could be small or they could be really big. It just kind of depends on what they want to give you. When we're getting into our systems of equations, we'll have, depending on how many variables we have, that'll kind of determine the size of our matrix, whether it's like a 3 by 3 or a 2 by 2. If they switch the dimensions like 4 by 3, that's going to change what that means. So you can't just write the matrix dimensions in any order. It's always rows by columns. So if it switched around 4 by 3, that would mean there's 4 rows now and 3 columns instead. Okay, here's an example of that. This matrix here is an example of a 4 by 3 matrix, because if you notice, there's now 4 rows. Rows, remember, go this way. And then there's 3 columns. Now, if you also notice that those elements that they have in there, they're kind of labeling them kind of with a lot of letters and numbers. What this first one means is that this would be row 1, column 1. So that very first term, if you're talking about its position in the matrix, it would be described as it's in row 1 and it's in column 1. So we have a couple of blanks in here that we want to fill in. So let's start here on kind of right underneath. That first whole row is filled in. Let's go to the next one. That middle one isn't filled. How would you guys write that? What row is this one in? 2. And what column is it in? 2. Okay. If you need to, you can think like this is 1, 2, 3, 1, 2, 3, 4. Okay. If we go here to the next empty blank, what row is this one in? 3 and column 1. Okay, and then this last one would be row 4, column 3. Okay, so if they start talking about, especially when we get into matrix operations, we might talk about, we're going to take this number times this whole row. We're going to take this number times this element inside of a row. Being able to understand what they mean when they write it like that is helpful to know what term or element are they talking about. All right, so we want to be able to practice this. So I'm going to let you guys take a look at this matrix here. You're going to name it. So remember that the name is using a capital letter. Size would be its dimensions. And then I want you to tell me what would be the entry in these 2 positions described. So go ahead and take a minute here and fill out those blanks.
Do you see what's going on?
I don't know why you continue to sit with them. They're so mean to you.
Or where else am I gonna go?
You go sit with Brack. He's all
Over
alone.
the other side of the best friend.
You go sit by Josie. She seems pretty nice. And Fabian. They wouldn't pick on you. All right. How would you guys name this matrix? What would be just the capital letter we would use for the name? D. Size, rows by columns? 3 by 2. Okay. What entry is in row 2, column 1? What'd you say? 4. And row 1, column 2? Good. -2. Good. All right. Okay, so now what I want to talk about is how we use a matrix to write out the information provided to you in a linear system. So we're starting to get into how could we use this if we wanted to solve for a system of equations. And I don't want to use substitution or elimination. Instead, I want to use a matrix to help me out. What you're going to do is you're going to have your matrix kind of outline. Your variables with the constant are going to be on the right side of the equal sign. And then you're going to place your coefficients inside the matrix if it's something is missing. So if a variable gets skipped over in an equation, like there's x and a y in the first one, but there's no y in the second one, you have to put in a 0 to replace that. You can't just ignore it and like pretend like it's not there. So the example that I have, we're working with this system here. So I've got a system with 3 variables there. X minus 4y plus 3z equals 5, negative x plus 3y minus z equals -3, and then 2x skips over the y, minus 4z equals 6. We've saw stuff like this in the last chapter, and we would solve using a system of equations. What I'm going to do first is show you how this looks like in a matrix. If they only wanted the coefficient matrix, that means you're only focused on the variables. So only the pieces that are on the left side of the equal sign would come down here to the coefficient matrix. And only the numbers that are in front of the letters. So notice how down here there's no letters, there's just the numbers. So 1, -4, 3, -1, 3, -1. That's all coming from those letters up above. If I want to fill in the bottom row, because they don't have that, what number would I put first? What's in front of the x on the bottom row? 2. Is there a y? -4 would go with what? The z. So it'd be 2, 0, -4. Okay. Now the same thing is being shown over on the right side, but this is called an augmented matrix. So this means you're going to include the constant. So you're going to include what comes after the equal sign. So again, they have all the coefficients the same. Notice how they drew in kind of this like line though. That's separating your coefficients from your constants. So the letters from the regular number on the other side of the equal sign. The -4 is still going to come down here because those are still the numbers in front of your letters. But what's the last number I need to add now? 6, okay, because it says equals 6. So it's the same thing, but it's adding on those constants at the end. This form here is what we would use when we're trying to solve a system of equations. Okay, we're not going to get quite there yet. We're not solving right away. What we're going to do first is work with just the coefficient matrix and talk about how we can start doing some operations with these rows. So if you guys go to the next page here, we're going to do some what's called elementary row operations. Okay, it's called elementary because it should be simple. Okay, meaning you're multiplying, you're dividing, you're adding, and you're subtracting. Okay, we're not going to throw in letters. We're not going to be squaring stuff. We're not going to be square rooting things. We're keeping it really basic with the math that's happening here. We can interchange rows if we feel like that would be helpful. That means you can take a row 1 and row 2 and you can have them flip-flop if you would like to. You can multiply a row by a constant, but we're not ever allowed to multiply by 0. because that would just cancel out the whole thing and that would be pointless for us. We can add a row to another row. We can subtract rows. We can also multiply a row and then add it to something if we feel like that would be helpful. So they're going to kind of walk us through and have us just do some of these elementary operations here. So the first example I have is they want me to interchange row 2 and row 1. That means they want me to take this row, and they want me to kind of flip-flop them. So if you look at what they did on the second matrix, they just took the second row, they wrote that on top. They took the first row, and they wrote that in the middle. That's all it looks like when you're interchanging. You're just doing a little switch. Okay, so if we come back to this original matrix, okay, so I'm going to put a star here. This is where we're starting. The practice says interchange row 1 and row 3. What would that look like now? You're taking these two and you're switching them. So how would you guys write that down below?
2, 0, -4, and then below it, -1, 3, -1, and 1, -4, 3.
Good, perfect. That's all you got to do. Okay, that's one operation we could do. Interchange those rows if we feel like it would be helpful if we're trying to maybe get like terms together. Okay, another elementary operation we could do is we can multiply by something. So I'm going to multiply row 2 by 2. So I'm going to just focus on this row here. I'm taking it times 2. Think about the distributive property there. You're multiplying all those numbers in that row by a 2. So -1 times 2 becomes -2. 3 times 2 is 6. -1 times 2 is -2. That's where these new numbers came from. Everything else about the matrix stays the same. They didn't multiply the top row or the bottom row by a number. They left those as is. Okay, so what you guys can do now is, again, this is your original matrix, this one here. Do the practice now. Multiply row 3 by -1/2. Watch your signs on this one. Okay, you should only have taken the bottom numbers times the -1/2. And what did you guys write? What's 2 times -1/2? -1. 0 times -1/2.
You can get a -0 or
It would just be 0. And then -4 times -1/2?
2.
2. Okay. So that's, again, another example of an elementary row operation. We just did a real quick multiplication. Okay. Last example I have here, kind of on this page, is doing a little bit of combining those things. So we want to multiply row 2 by 2, and then we want to add it to row 3. So they wrote that here. And this is kind of a notation that you're going to see a lot, where I might start writing things out like this, where I'm going to put 2 times R2, which stands for row 2, and then plus R3, which is row 3. So we're just, again, working with these two rows, but we took 2 times the -1, the 3, and the -1 first, and then we added it to row 3. Now that's going to affect row 3. So that's why these numbers change. Everything else about the matrix, though, stays the same. If you guys look up here, these are the exact same numbers, and these are the exact same numbers. The only thing that got affected was that bottom row. We took 2 times row 2, and then we added it to row 3. And that's going to impact row 3 and change those numbers. So that's where that 0, 6, -6 came from. Okay, so on this next one, again, this is your original matrix here. What they want you to do is take 3 times, or take row 3 times the -1/2, and then add it to row 1. So the row that should change is your top one. The bottom 2 rows should stay as it is. But you're going to take, for this top one, you're going to take -1/2 times R3, row 3, and you're going to add it to row 1. So only that top row should change. So I want you guys to take a minute to do that. Find those new numbers. So what'd you get for new numbers here? 0, -4, and 5. Okay, earlier, I'm just going to kind of circle back up here. This problem that we did here, it's still showing up on my screen. This was when we took -1/2 times row 3. So you already did that operation earlier. So you're taking -1, 0, and 2, and you're adding it to this row. So that's why -1 plus 1 is 0. 0 plus -4 is -4. And 2 plus 3 is 5. All right, so let's get into now why would we need to do this? Why do we need to do these elementary row operations? What is that leading us into here with these matrices? Okay, there's something called Gaussian elimination, which is using matrices to help us solve a system of equations. So those examples that I had before, those were maybe only the coefficients that you were working with, but that is still coming from a system of x, y, and z. So now what we're going to do is start looking at an actual system and how can we solve and do these elementary row operations to help me solve for x, y, and z. Kind of the steps that are involved in this process is you want to get your diagonal to equal 1. So that would be like row 1, column 1, all the way down to like row 3, column 3. You want those to all be 1s. And then you want everything on either side of the diagonals to be 0s. Now, when we do that, usually we start on like the bottom half left side of the diagonal to try to get to 0 first, and then we work on the other side. The reason why we do that is because those diagonals, if they're all 1s, they're representing an x, a y, and a z. And if everything else is 0s in there, then your answers at the very end, where your constants are, is going to help you solve for your x, y, and z. So I'm going to show you how this works on this first example. This is my system here. Okay, so they took all those coefficients, all the numbers in front of the x, y's, and z's there, and all of my constants. This is the same matrix that we were working with on the previous page. Okay, but now we've added on the constants at the end. So they drew in that bar, and they've got the numbers that are equal to on that side. My goal here is to get the diagonal, the 1, 3, the -4. So these numbers, I want to make them all become 1s. And I want all of the numbers here to the left. So I want this -1, 2, 0. I want all of those to be 0s. Okay, that's kind of your goal. Now to do that, we're going to do those elementary row operations. So we're going to start adding rows together. We're going to multiply rows. We can interchange if we feel like that would be helpful to us. I would say most of the time when I do these, I don't do a lot of interchanging rows. I mainly do multiplying, adding to try to get numbers to cancel out. Okay, or I do maybe dividing by number if it seems like it's going to help me. All right, so over on the left-hand side, they're kind of showing you like what they want you to do, like what's your goal as far as when you're finished with this matrix, what you want to see happen here. So the first thing is they want row 1, column 1 to be a 1. Well, if we look at that, it's already a 1, right? So we're set off already that first number is a 1. That's great. I don't have to do anything to it. So now what I want to do is underneath that where it says row 2, column 1, so that would be this number here, I want that to be a 0. Okay, to do that, that means I'm not going to impact row 1 or row 2. So sometimes what helps is if you just write those out. So I'm not going to do anything to row 1, and I'm not going to do anything to row 3. I want to manipulate this a little bit to help me get a 0 there for that second row. What I see right away is that my top 2 rows, it's a 1 and a -1. If I add those, they're opposites, it's going to become a 0. So what I like to do is I like to write next to the row what I'm doing. So I'm going to write, I'm taking row 1 plus row 2. This helps me keep track of the operations I'm doing so that I can actually do the math and then get my answer here. So if I add 1 plus -1, that's 0. And then I'm back up here. I'm adding these 2 rows. What's -4 plus 3? -1. 3 plus -1. 2. And 5 plus -3. 2. Okay? Now we're going to keep going. I would really like that second, where that -1 is that I just wrote in red, I'd like that to be +1. because again, my goal is to get my diagonals to be 1s. It'd be really easy for me to do that because what do I need to just do to row 2? Multiply by -1. So again, I'm going to leave row 1 and 3 unaffected. So I'm just going to copy those down quick. And we're going to take -1 times row 2. That's just going to change all the signs. 0 doesn't have a sign, so it just stays 0. -1 becomes 1, and the 2's both become -2's. Okay, so I'm not going to keep this up here, but just to look at this stuff, guys, this is where we're at so far. I like what I see because I'm seeing 1s in my diagonal, and I see a 0 there. All right, now what they're telling me to do in my next one is they want me to make row 3, column 1 a 0. So they want to get this 2 to become a 0. Any ideas on how we could do that?
Row 3 subtract 2. Or,
Row 3 subtract 2, you said?
yeah.
I don't think we can just necessarily subtract from a row.
Yeah.
We'd have to subtract rows together. So is there a way we can manipulate row 1
By -2.
and then do something with row 3?
Subtract row 3.
Okay, so if we take -2 times row 1, I'm just going to write that down here. -2 times row 1. Would I want to subtract row 3, or if it's negative up here now, would I want to add it? So I'm going to write plus row 3. Okay, I'm not going to do anything now to rows 1 and 2. So I'm going to write out 1, -4, 3, and 5, 0, 1, -2, -2. The row that's changing now is the bottom one. And we're thinking we're taking a -2 times that top row, and we're adding it to row 3. So you're taking -2 times 1 plus 2, which would be 0. What would be -2 times -4? 8. And then plus the 0 from row 3 would be 8. -2 times 3? -6. And if we add -6 to -4, -6 plus -4. And then -2 times 5, -10. -10 plus 6, -4. Now, it may not feel like we did a whole lot there because some of your numbers are increasing, but you did get a 0, which we needed. So now if you look at that first whole column, it's 1, 0, 0. That's great. That's what you want. Now, in the middle column there, we have a 1 in the middle, but I need to get that 8 to become a 0. Okay, I need this 8 to 0 out here. So how can I do that? How can I make this 8 become a 0? So take 2 times row 1 and add it to row 3. Okay, so we're not doing anything to rows 1 and 2. So again, I'm just going to copy those down. Okay, let's do this here. So again, we're working back with this matrix. We're taking 2 times this row and we're adding it to this row here. So you're back on your previous matrix when you're doing your math to write out your new numbers here. So 2. Well, that's okay though. You know, that's going to happen sometimes. Okay, we'll get there. So let's take, okay, 2 times 1 would be 1, plus 0 would be 2, right? Oops, let me write that right. 2 times -4 would be -8, plus 8 would be a 0. 2 times 3 is 6. 6 plus -10 would be -4. 2 times 5 is 10. 10 plus negative 4 is going to be 6. Okay, so he pointed out, like, wait a minute, we had a 0, now we're back up to a 2. That's going to happen sometimes as you're kind of working through your matrices, where it's unavoidable at times where something that you zeroed out, it's maybe going to have to pop back up to a number. We can still resolve that at the end. Okay, so we'll figure that out here in just a minute. Now, the next thing that they wanted me to do here is make row 3, column 3 a 1. So they want this negative 4 to become a 1. Okay, so let's think about how we could do that here. We could do that. I'm also wondering if maybe we go back. Is there another way to make the 8 become a 1?
Throw this up.
It's a lot of math. I'm going to erase this, and I'm going to see if we can rewrite this a little bit. What if we took negative 8 times row 2? And then we added it to row 3. So instead of doing this positive 2 up here, because then maybe we won't have a 0, become a 2. I'm going to take negative 8 times row 2. So I'm taking negative 8 times all of these numbers here, and I'm going to add it to the bottom row. Because negative 8 times 0 would be 0, and plus 0 would be 0 here. So that fixes that problem. Negative 8 times 1 would be negative 8, plus your 8 is 0. What would be negative 8 times negative 2? 16. 16 plus a negative 10 would be 6. And then we've got kind of the same situation here. Negative 8 times negative 2 is still 16, plus negative 4 would be 12. That fixes out that issue that we had where we no longer have that 2. Okay, now is there a way where we could make the 6 become a 1? So I'm not doing anything to row 1 and row 2.
Can you divide?
We can divide. What would you like to divide by? 6. So you want to just take row 2 divided by 6? Row 3, I mean. If we take 0 divided by 6, you get 0. 0 divided by 6 again is 0. 6 divided by 6 is 1. And 12 divided by 6 is 2. Okay, now what they're showing you down here is how you would finish this out. Once you get something that looks like this, one of the rows has all those zeros except that last one. They're saying that z here, z equals 2, which is what they have here. Then what you can do is go backwards in your problem, because this is a simpler version of these equations. The second one is y, so I'm just going to point up here. This one here is y minus 2z. Now we know z is 2, so they went ahead and substituted that in. So this becomes y minus 4 equals negative 2, and they solved for y and they got 2. Once you have 2 of your letters, you go back to that top equation. That's the x minus 4y plus 3z equals 5. You plug in your y and your z, and you can solve for your x. We'll do more of this tomorrow. Okay, and we'll continue to practice using our substitution.